associate homogeneous equation. So for example, for the second order, okay, for the second order, we have a1, oh, it didn't go, a1 y, no, a2 y double prime plus a1 y prime plus a0 times y equals g of x. So for the associate homogeneous equation of this second order, gonna be a2 y double prime plus a1 y prime plus a0 y equals 0. So we just ignore the gx for now. And for this part, you're gonna get the solution to this homogeneous version of it as y equals c1 y1 plus c2 y2, and set it aside. And this y1 and y2, like what we went over earlier, they are fundamental set of solutions of the homogeneous equation, and they are related to each other because they are linearly independent solution. So we can write as a linear combination. Okay, and then for each gx, if you have different gx, you're gonna have solution is called yp, okay, which is part of the whole solution, part of the general solution. So that means if you have g1x, you're gonna have yp1, which is the same differential equation. You have g2x or different function form on the right hand side with the same homogeneous version on the left. So you're going to have different yp. So the yp, that's why it's called a particular solution, because it depends on the non-zero term on the right hand side. Okay, and then when you put them all together by the superposition principle of the not the superposition principle yet, for the, what is it called, let me see, the general solution of, so general solution of the non-homogeneous differential equation gonna be in the form of y equals the solution from the associate homogeneous equation, which is c1 y1 plus c2 y2, and then plus yp. So part of them is from the homogeneous version of it, and the other part is from depending on the gx. And the linear combination of the y1 and y2 is called yc, which is called the complementary solution. Okay, therefore the solution of the non-homogeneous equation in general way, we're going to write it as yc plus yp. So two different portions put together as a solution of the non-homogeneous equation. And then the yp, for the superposition principle of the non-homogeneous equation, okay, if the equation is in the form of, let's see, the same differential equation, this is the second order, like a2 y double prime plus, I try to make it, let me, so I'm going to put this in the box here. So this is my star, okay? So the left hand side of the star is the same, but the right hand side is G1 plus G2 plus G3 all the way to Gn, okay? That means the YP of the particular solution, when you have like many of the G terms on the right hand side, but we know each G provide you each particular Y or YP. So same as the previous for the homogeneous equation, that you can tie them up, you can write them all together. But since for the non-homogeneous equation, each one is individual, you can write the solution YP of the homogeneous equation as, of the non-homogeneous equation as yp equals the sum of each yp that's corresponding to each g. And I'll show you in the example. I'll explain more in the example. Okay, so if you have only one term and you know that the particular part of it is yp1. But if you have the sum of the two different g's and each one you know that you're gonna give like different yp, you can add them all up as part of the particular solution of the same differential equation. Okay, question for this part? No. Okay, and then the next one, an example. For the example, let me see. This is one of the fun one, like y double prime plus 9y equals 27. This is the non-homogeneous because the right hand side is not 0. But the problem just asks you to verify whether yp equals 3 is a solution or not. Well, it's very, very easy, right? Because this is a constant term, yp prime or yp double prime is 0. The 0 here plus 9 times 3 equals 27, checked. And then when you do the second problem, and I hope you can observe, or you would notice something, because the solution is, the particular solution is 3. The quick way to get it is 27 divided by 9. So yp would be 27 divided by 9. Like this number divided 27. Okay, this is just for the case of y double prime plus the constant times y. When we get to chapter notes 4.3, you can see that, okay, how do we get, actually 4.4, how do we get yp equals 3? And what would be the rest of the answer? That would be part of the 4.3 plus 4.4 all together. But kind of at the beginning here, 4.1 give you pieces, piece by piece, and then you just collect them all and tie them up like jigsaw puzzles. They will come together at the end. Okay, and then for the second example, we have y double prime minus 8y equals 16. And see the yp that provided is -2. You can make a guess by, okay, 16 divided by -8 is -2. So this is the way that we can observe it, but it doesn't work for all second order differential equation, just for this particular case. And for the second one, I'm gonna skip the part that you have to verify, because that part I'm sure you guys can handle that. But the second example of 4.1 pretty much saying, like, if you have y double prime minus 3y prime plus 4y equals -16x squared plus 24x minus 8. So you get the particular solution for this case, for the case that, for this particular g. Okay, this is the first g, so I'm going to put as a g1, and this is yp1 equals -4x squared. And then the second part, or the part b, y double prime, the same, you see the left hand side, they remain the same for 3 terms, which is called the associated homogeneous equation part. So y double prime minus 3y prime plus 4y equals 2e to the 2x, and this one is called like g2 of the x. For the second form of the right hand side, that keep the left hand side all the same. So yp2 equals e to the 2x. And next, for the last one, the left hand side still the same. The right hand side 2x e to the x minus e to the x. Okay, that's and the provided yp3, or the particular solution for this particular g3x here is x e to the x. And then the wrap up of this package, or this non-homogeneous superposition set, for y double prime minus 3y prime plus 4y equals -8x squared plus 12x minus 4 plus 2e to the 2x plus 6x e to the x minus 3e to the x. What is the particular solution to this messy g, like all combination of the g here? And when you see, like when you break it up, like break it down into each one of them. See the first, the G1, you have 3 terms, which is the power 2, power 1, and the number. When you look at this, negative 8x squared plus 12x minus 4, that is what a half of the original G1, right? A half of original G1. And then the second piece, the 2e to the 2x, that is the same as the G2x. And the last 2 terms, that is triple of the G3. G3. So then the particular solution for this, the YP, is the combination of the YP1, P2, P3, depends on the coefficient in front of the each G. So for the each G is a half of the G1, so gonna be a half of YP1. And the second one is the same thing, so gonna be the same, like YP2. And the last one gonna be triple of the YP3. That the combination of them gonna be the particular solution of the long expression of the G. Okay, so therefore the YP is a half of negative 4x squared, which is negative 2x squared, and then exactly the same as YP2, which is e to the 2x, and triple of the YP3, which is 3x e to the x. That's the use of the superposition principle of the non-homogeneous equation.